So now we need to look a little bit more in detail about monosaccharides and learn about how those work and how to draw them and how they're structured and everything. And then we'll go into having more complex structures. But starting with just monosaccharides, more complete definition of these is that they have 3 to 8 carbon atoms in a chain. So this chain can be linear or cyclic. So we'll see, I think it's in section 3, maybe section 2. I think it's 3 though. We'll be learning how to draw the cyclic forms. So right now we're going to stick with linear, but realize that we will get to the cyclic forms soon. And then one of the carbons is going to be a carbonyl group. So if we have we have 2 different kinds of carbonyl groups that we could have. If it's an aldehyde, then it's classified as an aldose. Or if we have a ketone, the sugar is then classified as a ketose. Those are the 2 major forms of sugars that we have, aldoses and ketoses. You'll notice that I'm saying ose at the end of these. So whenever we have a sugar, the ending of the word is typically going to be ose. And we'll see right now when we're classifying these that you keep that ose at the end to signify that you're talking about a carbohydrate or a sugar. And then additionally, one key thing to mention as well is that all carbohydrates have alcohols. So we talked about we have aldehydes and ketones as part of those functional groups where we have in sugars, but if it has a ketone, it typically won't have an aldehyde, or at least the most basic sugars. If it has one ketone, it won't have an aldehyde. But every single sugar, every single carbohydrate will have alcohols, regardless of its type. Oh, what is going on? Let's try that on a new line. Okay, so we will specifically be learning how to do sugars with carbon lengths 3 through 6. So we're not going to worry about the bigger ones, 7 or 8. And so to classify or to name these sugars, we need to have a signification of the number. So we already said ose is the ending of our names. So when we have 3 carbon atoms, you'd think that we would be like propose or something like that, since we just finished talking about organic chemistry, but in biochemistry, they change up the prefixes a little bit. So a 3 carbon atom carbohydrate would be a triose. So tri is the prefix here for 3. The prefix for 4 is tetrose. So, or the name is tetros. The prefix is T-E-T-R. I don't know how to pronounce that without the O-S-E. Tetros. I don't know. Then we have pentose. So that's the same. And then hexose, which again is the same. So 3 and 4 are different. 5 and 6 are the same. So we have our classification based on our number. Then we also have our classification based off of whether it has an aldehyde or a ketone. So for example, here we have an aldehyde. So that means it's an aldose. And then over here, you see we have our ketone. It can't be on the very end anymore. It has to be a little bit, or it has to be 1 carbon in is where it's always going to be. And that is going to be named a ketose or classified as a ketose. So specifically how we put this all together, we need to name them now, have a singular name to be able to determine whether they're an aldehyde or ketone based, and then also how many carbon atoms they are. So let's put it all together and classify these sugars. So I'm going to start out with what kind of sugar it is. So I like to put a square around the particular type of functional group that's in there, the type of carbonyl that's in there. So in this one, we have aldehyde. So I'm going to write ALD. So I'll even start with that. ALD, I think it's ALDO. Yep, it's ALDO. So we had aldose before, but we also have to add in the number. So we're going to put the aldehyde or ketone functional group, then the number, and then ose at the end. So we're going to start with aldo, and then we're going to number how many of carbons we have. So we're going to start with the carbon of at the very top of our chain. So we'll talk about what these particular structures, how we make them and everything, but we're going to start with the very top. That's carbon number 1 and label all the way down. So we have 3 carbons. So we're going to have aldo tri and then ose at the end to show that it's a sugar. Aldo tri ose. Let's try another one. So I'm going to put a square around my functional group, and that's a keto. Write keto first, and then we're going to number our carbon chain all the way down. 1, 2, 3, 4, 5, 6. Keto hex, meaning 6, and then ose at the end to show that it's a sugar. So we have a keto hexose is the total classification of this kind of sugar. So there's a couple practice problems for you here to do on your own. So please, please, please take a moment and try these out. And I'm going to go through them really, really quickly right now. I'm going to go ahead and put a box around each of my functional groups so I recognize which ones they are. Here we have an aldo, keto, aldo, keto. Okay, and then let's go ahead and number our carbon chains. So we always start at the top, 1, 2, 3, 4. So let's go ahead and name them now. So I'm going to have aldo tet, T-E-T-R-O-S-E. So this one is an aldo tetrose. Aldo showing that we have an aldehyde, tet, T-E-T-R, showing that we have 4 carbons in our carbon chain, and then ose as our sugar. Let's keep going. 1, 2, 3, 4, 5. So now we have keto, pentose. I'm actually going to go ahead and change these colors real quick so that we match our color scheme from before. Ketopentose is the name or the classification of that particular molecule. And then let's keep going. So we have 1, 2, 3, 4, 5 again. So we'll have an aldo pentose. Again, we have an aldehyde functional group at our carbonyl position. And then we have 5 carbons, so pent, and then ose showing it's a sugar. And then our last one, we have 1, 2, 3, 4, 5, 6 carbons long. So we will have a keto hex showing 6, and then ose showing a sugar. Okay, so that's how we classify monosaccharides in especially their linear form. We'll have to do this in their cyclic form as well. And yeah, that's where we're at.